Before we get into studying science, it's important to define exactly what it is. That might sound easy to define a word, but the word science actually means a way of knowing, and it comes from a Latin word meaning knowledge. But don't you get knowledge from all of your classes? Why do you have just one class, or maybe more than one if you're lucky, that's called science? If you look at this picture, it says everyone gets in as long as they behave scientifically. Pause the video right now and pick out what from the picture you would call scientifically. So like I said before, science is a way of knowing. But how do you get to that knowing? That's really what makes science science. And there's a lot of different ways of knowing depending on what you're trying to learn. So the first thing that makes something science is if it involves the natural world. So it includes things like how different substances behave in the natural world, like elements or compounds like water. And that's chemistry. It includes how things move in the natural world and what happens if you push or pull something, and what kinds of things cause that pushing or pulling, and that's physics. It includes how the earth itself behaves, the rocks, the bodies of water, volcanoes, and that's earth science or geology. And also how living things behave and interact with their environments and other living things, and that's biology. But even more than just this body of knowledge that we think of as science, science is the process of obtaining that knowledge about the natural world. So just to recap, science is the process of obtaining knowledge about the natural world and also that body of knowledge that you've obtained. So depending on what kind of knowledge a scientist wishes to obtain, they might go about gaining this knowledge in many different ways. Some scientists might observe the natural world and record what they see or measurements they make. They might observe things like the ocean temperature and how many of a particular type of organism live in a certain area, or how a certain drug affects how many times the heart of a specific animal beats. Science always involves asking questions because that's what drives science. If you didn't ask a question about the natural world, you wouldn't have the motivation to learn something new about the natural world. And many times doing science itself makes a person come up with even more questions than they started with. Experimenting is probably what most people think of when they think of science. And a lot of scientists do experiments to see how one thing affects another, but not all scientists do experiments, and not all experiments teach you something valuable about science. And so we're going to learn a little bit later on what makes an experiment a good experiment that actually teaches you something. Another way of knowing about the natural world is doing research, and that research might involve talking to other people or looking things up on the internet or in textbooks or going to the library. If there's something you want to know about the natural world, it's possible that someone else already knows it or has some information that's going to help you figure it out. It might give you a good idea of how to set up an experiment or what sort of data to collect when you make observations or what other questions you should consider in answering your own question. Analyzing data goes along with making observations and experimenting. It's asking the question, what do my observations or experiments tell me? What have I learned seeing this or doing that experiment? Analyzing data might involve making graphs, comparing two or more things in a table, or arranging things into a chart to highlight the parts that are important to your question. Finally, all scientists collaborate. They ask each other questions, work together to find solutions, help each other interpret data, and share questions, data, and conclusions they've come up with. It helps other scientists answer their own questions, inspires them to think about something in a new way, or gives them ideas about other experiments they might want to do. This might make science seem very broad, like you could ask a question or make an observation about almost anything, and it's all science, but that's not true. Science does have some limits, and there's three main limits. So the first limit is science doesn't make any judgments or form opinions, like if something is good or bad, or right or wrong, or which one's the best or the worst. It simply states the way something is perceived based on the observations or experiments. Science also doesn't make decisions about how knowledge should be used. People make those judgments. Scientists know how to change the genes of some organisms, but should we do this? That's not science. That's something for people to decide. And lastly, science does not involve the supernatural. It only deals with things that can be explained through observations and conclusions that can logically be made from data that's reproducible, meaning under the same conditions, another scientist could collect similar data. If If that can't happen, if it's not reproducible, it's not science. So science is very broad because there are so many things that can be studied in the natural world, but science doesn't make judgments about anything, and it doesn't involve the supernatural. It also doesn't tell you how to use that science or use that new knowledge. There's a few misconceptions about science it's important to clear up before we start our study of the living world this year. Science is not just a set of facts, it's a process. There are some basic things that have been observed over and over in science, so it does make up a body of knowledge. But science class really isn't science if you're just sitting and reading those things in a textbook. It's all about doing, and so we're going to do a lot of what was on that last slide: observing, asking questions, experimenting, researching, analyzing data, and collaborating. It's also not true that science doesn't change. Science is always changing. People used to think that the world was flat and that the Earth was the center of the solar system, or that you could cure diseases by letting a person bleed. Well, you know all of those things aren't true anymore, but it used to be considered that was good science. In science, you can never prove anything. You can only gather evidence to support your claim. There are claims that you can make that have some evidence that doesn't support it, and so you'd have to say your claim was wrong. Proving something sounds like there's no arguing with it, that it's right. But scientists do more, but as scientists do more experiments and learn more about the natural world, they may come across data that doesn't support that claim. So you can always be disproven or wrong, but you can never prove anything in science. Finally, not all scientists look like Albert Einstein. Scientists are young and old, they're male and female, they come from all over the world. They're not always doing experiments like the scientists on the last slide. They're anyone engaged in observing the natural world, asking questions, experimenting, doing research, analyzing data they or someone else has collected, or anyone collaborating with others to do any of these things. They're all scientists, and you're going to be a scientist in this class every day this year. So now in your notebook, make a chart and fill in the best you can based on what you just learned and what you already know. What is science? What is science not? What are some examples of science? And what are some non-examples of science?